Hi, this is Somaiah, working as assistant professor in the Department of Mechanical Engineering at Institute of Aeronautical Engineering, Hyderabad. So, in the previous classes, we have gone through the boundary layer formation and how it is going to be formed. We have seen the various types of boundary layers with respect to the types of fluids and types of flows. So, today I'm going to discuss about boundary layer separation. In the boundary layer separation, when the solid body is immersed in a flowing fluid, if the solid body is stationary, when if fluid is flowing behind the stationary solid body, then gradually formation of a the boundary layer will be existing. So, as an account of so if it is solid body, on account of friction, the surface roughness, the first layer is going to be stick to it, and other layer which is coming into contact of this, the all adjacent layers will be reduced in its velocity. So all such fluid layers will be forming a boundary layer. So that in that boundary layer, the fluid particles will be retarded. So if the type of flow is converging, in case of converging, the velocity will be greater and the pressure will be decreased, where the thickness of the boundary layer will be decreased. So the boundary layer of thickness will be denoted by delta, so it will be decreased in case of acceleration. So, but when the fluid is going to be retarded, or in case of diverging passages, where the due to the retardation, where the thickness of the boundary layer is going to be increased. So, based on the pressure and based on the velocity, it can be the thickness of the boundary layer is going to be increased or decreased, or sometimes the boundary layer will be separated from the boundary, and in some cases the boundary layer can be controlled in order to in order to stop the formation of the boundary layer. We can prevent it by using some methods. We can prevent the formation of the boundary layer, and in case if the boundary layer is going to be formed, what are the precautions is going to be taken, and when it is going to be separated, and what are the different methods to control the boundary layer we are going to observe. So when a solid body is immersed in a flowing fluid, a thin layer of fluid called the boundary layer is formed adjacent to the solid body. So as whenever the fluid is moving and the solid body is stationary, then the first layer which is coming into contact of the solid body will be stick to that surface. So thereby it starts forming the boundary layer by stopping the kinetic energy of other the adjacent fluid layers which are coming into contact of its stop layer. So in this thin layer of fluid, the velocity varies from 0 to the mainstream velocity. So in the boundary layer, when the boundary layer is formed like this, so here the velocity will be 0 at this point, and it will be increased to the mainstream velocity, capital U. Along the length of the solid body, the thickness of the boundary layer increases. The fluid layer adjacent to the solid surface has to do work against surface friction at the expense of its kinetic energy. So thereby some of the kinetic energy will be lost. This lost kinetic energy is recovered from the immediate fluid layer in contact with the layer adjacent to the solid surface through momentum exchange process. So thus velocity of the layer goes on decreasing. So whenever the layer is sticking and which is stopping the momentum of other layers, where the velocity will be decreasing. So along the length of the solid body, at a certain point, a stage may come when the boundary layer may not be able to keep sticking to the solid body if it can't provide the kinetic energy to overcome the resistance offered by the solid body. So therefore, at that stage, the formation of the boundary layer, and it may not be continued to the form, therefore it will be separated from the boundary. So in other words, the boundary layer will be separated from the surface. This phenomenon is called as boundary layer separation. So whenever the velocity is going to be increased, where the pressure will be decreased, where the thickness will be reduced, but in case at some place the velocity becomes 0. So therefore, at that stage, so therefore, the solid from the solid surface, the boundary layer need to be separated. So that point is known as the boundary layer separation. The point on the body at which boundary layer is on the verge of separation from the surface is called the point of separation. The point of separation means at that point it starts leaving the solid body. So in this diagram, we can see how the solid body is kept in the flowing fluid and how the boundary layer is forming and how it is going to be vary in its thickness. So from A to C, from A to C in this area, so this is a converging portion. In this converging portion, what is going to happen is the velocity is going to be increased, at the same time pressure gradient will be reduced. So in a convergent portions, while the velocity is increasing, the pressure is going to be decreased. In this case, there will be small thickness of a boundary layer can be found. So as the fluid is going to be accelerated. So but after point C, there the divergence is going to be stopped. So in this divergence, so what is going to happen is velocity is going to be decreased. So velocity is going to be decreased and pressure at the same time it will be increasing. So due to the positive pressure gradient, dou P by dou X, whenever it is greater than to the 0, so in the due to that positive pressure gradient, the thickness of a boundary layer is going to be increased, but at the point D, sharply, so where the velocity becomes 0. If the velocity is becoming 0 at point D, then the boundary layer may not stick to its surface. Therefore, the reverse flow will be taken place in this direction. Boundary layer will be separated from this point onwards, and within this region, again due to the reverse flow. So whenever the reverse flow is there, so due to this reverse flow, another boundary layer will be formed, and if you join all these points, then the separation streamline will be obtained. So in the divergence of the pressure and velocity is going to vary due to the positive pressure gradient and negative velocity gradient. There will be a chance of leaving the solid body. Therefore, the boundary layer may not it won't stick to the solid body at point after beyond point D. It will be separated. It will be separated from the solid body, and there will be a reverse flow will be existing. If the pressure gradient dou P by dou X is 0, then the boundary layer continues to grow in thickness along a flat plate. So, but during the acceleration and till the pressure gradient becomes 0, and in the negative pressure gradient also, it is going to be increased in thickness. The thickness will be varying. So, but in retarded flow, there will be greater thickness. In accelerated flow, there will be less thickness. But only the thickness will be is a function of the pressure gradient, pressure and velocity. With the decreasing pressure in the direction of flow, the negative pressure gradient will exist. The boundary layer tends to reduce in thickness. So due to the negative pressure gradient, the boundary layer thickness, this delta will be small up to in the convergent portion, as there is a acceleration will be taking place. Acceleration will be going to be taken place. However, with the pressure increasing in the direction of flow, with the positive or adverse pressure gradient, the boundary layer thickens rapidly. So in case of a divergent flow, so the here from D, after D in this portion, there will be divergence will be taking place. Due to that, the delta is going to boundary layer thickness is going to be increased. So that is due to the positive pressure gradient, where the velocity will be negative. Velocity gradient it becomes lower than to the 0. Then in that case, the positive pressure gradient will be existing, and the flow will be retarded. Due to that, there will be greater in thickness of a boundary layer. The adverse pressure gradient plus the boundary layer decreases the momentum in the boundary layer, and if they both act over a sufficient distance, they cause the fluid in the boundary layer to come to rest. So therefore, The retarded fluid particles can't, in general, penetrate too far into the region of increased pressure owing to the small kinetic energy. Due to this small kinetic energy, they won't penetrate into the high pressure region, or high pressure where the high pressure particles are there. So thus boundary layer is deflected sideways from the boundary, separates from it and moves into the mainstream. This phenomenon is called as separation, or boundary layer separation. At D, it will be deflected and it will be mixing with the mainstream. As the fluid flows around the surface, it is accelerated over the left hand section until point C. See, until point C, this will be accelerated on left hand section. So this will be accelerated. At the same time, here behind point C, there will be retardation. The velocity just outside the boundary layer is maximum. At this section, the pressure is minimum. Thus, from point A to C, the pressure gradient dou P by dou X is negative, and the pressure force on an element of fluid in the boundary layer is in the direction of flow. So, which counteracts to some extent the slowing down the thickness of a boundary layer. So, therefore, the thickness up to from A to C, the thickness of a boundary layer is small. However, beyond point C, the pressure increases. Hence, net pressure force on element of fluid in the boundary layer opposes the forward flow. So, thus, at a certain distance on downstream of point C, the fluid near the boundary surface is soon brought to the standstill. So, the value of the velocity gradient dou V by dou Y at the boundary surface is then 0 at point D. So at this point, this is a separation point where the velocity dou V by dou Y is equals to 0. That is standstill position. So after that, it won't continue with the solid surface. The formation of the boundary layer will be separated and it will be mixing with the mainstream. At D, at point D, we can observe it will be separated here. Afterwards, it will be mixing with the mainstream velocity afterwards after point D. Up to point C, there will be gradual thickness. A small thickness will be there, but after C, there will be a divergence where the velocity is going to be 0 at point D, but velocity is becoming negative after D. So after where the pressure gradient becomes positive. In that case, the reverse flow will take place, and due to retardation, the right side of this point C in this divergence section. Due to this retarded flow, the thickness of the boundary layer will be increased, but it won't stick to the solid body. It will be separated and it will be mixing with the mainstream fluid. The fluid is no longer able to follow the contour of the curved surface and it separates from it. The separation of flowing fluid from the boundary first occurs at a point where dou V by dou Y at the boundary becomes 0, and this point is known as a separation point. So in this diagram, we can see the point D is known as a separation point. Yet as dou V by dou Y is becoming 0, it won't continue with the solid body, and due to this retarded flow as started, then it will be separated. So this point is known as separation point. The separation point is nothing but where the boundary layer will be separated from the surface of the solid body, and it will be mixing with the mainstream. On downstream of the separation point D, a further retardation of the fluid close to the boundary can even have a reverse or back flow at point E. So at point E, we can observe the reverse flow. In this way, you can draw here reverse flow. So from here, the reverse flow is going to be taken place. If all the points below which a reverse flow occurs are joined by a smooth curve, a line dividing the forward and reverse flows is obtained, which is known as the separation streamline. The separation streamline, that if you draw a reverse the streamlines over which below which reverse flow is taking place. So if you connect all that points, we will be getting a separation streamline. So that can be observed from point D to E. So if you draw furthermore the velocity distribution diagrams, we will be having the various reverse flow directions, the streamline passing over the reverse flow. So if that point is connected, then the particular point is known as the line is known as separation streamline. Here the pressure gradient here dou P by dou x is less than to 0, and here dou P by dou x is greater than to 0. So here this is known as the pressure distribution line. So this is the actual pressure distribution will be like this, but in case of ideal, the pressure distribution line should be like this. The most minimum pressure gradient will be obtained at the center. In a region in between the boundary surface and the separation streamline, as a result of the reverse flow, large irregular eddies are formed in which much energy is dissipated as heat. So whenever the reverse flow is taking place, there will be less energy particles and they will be rotating. So without any particular direction. So these are nothing but the eddies, irregular and low kinetic energy, actually whose energy is low. Therefore, the reverse flow is existing. So due to this low energy, only the particle will be following the reverse flow path, because they are all low energy particles will come into a reverse flow direction. So due to this eddies formation, the much energy is dissipated as heat. A separation occurs with both laminar and turbulent boundary layers, but laminar boundary layer is more susceptible to earlier separation than turbulent boundary layer. So both in these cases, in laminar and turbulent, also in transition, also there will be formation of boundary layer and also separation. So here there are the conditions based on that you can say whether the flow is separated or not. It's not separated. The boundary layer, whether it is going to separate or already separated, you can describe based on these conditions. If dou V by dou y equals to 0 is if it is greater than 0, if it is velocity gradient is greater than 0, then it will not separate or will remain attached to the surface of the solid body only. If the velocity gradient is equals to 0, if the velocity gradient is 0 means at a point D, in the previous slide, if the point D, at a point D velocity is becoming 0, at this standstill position, it won't continue with the solid body surface, it will be separated. So therefore, if the dou V by dou y is equals to 0 means that is virtue of separation, that is about to separate from the solid body. So is the dou V by dou y is equals to nothing but virtue of separation. If dou V by dou y less than to 0, if it is less than to 0, then flow as that means a negative velocity gradient indicates already the boundary layer is separated. So based on if the velocity gradient is less than to 0, then it becomes a positive pressure gradient or adverse pressure gradient will take place. Due to that, there will be a thickening of the boundary layer. So that means already separated. Based on the velocity gradient, we can say whether it is separated or not. Based on this velocity gradient, the pressure gradient also will vary, but it describes the thickness of the boundary layer. But in case of velocity gradient, by observing this, we can say whether the boundary layer is separated or at the verge of separation or already separated. So separation occurs with both laminar and turbulent boundary layers. Now here are some of the methods to control the formation of a boundary layer. So if the boundary layer is going to be formed, then how do you control it? In order to control it, in order to stop or preventing from the formation of boundary layer is one kind of thing. In order to avoid this separation, study this separation and formation of a boundary layer and measuring the boundary layer, all this thickness. In order to prevent it. You can after formation also you can prevent it, and without formation also you can stop it. Some of the methods we will see here how to control the boundary layer formation. So if the flowing fluid in a flowing fluid, if the solid body is kept as stationary, then there will be a formation of solid body. But if it is moving, then there is a less chance to formation of a boundary layer, and it won't form. But in other direction, there is a formation of a boundary layer. So in this direction, there will be no formation of boundary layer, but in other direction, there will be formation of a boundary layer. So in order to control, you can make as the fluid is flowing, you can make the solid object also move along with the flowing fluid. In that case, there will be you can prevent formation of a solid body. But in other direction, there will be formation of there will be small in thickness. The formation of a small boundary layer will be existing. The formation of boundary layer is due to the difference between the velocity of a flowing fluid and that of the solid boundary. As such, it is possible to eliminate the formation of a boundary layer by causing the solid boundary to move with the flowing fluid. So then we can avoid the chance of formation of a boundary layer. Such a motion of the boundary may be achieved in the simplest ways by rotating a circular cylinder lying in a stream of fluid, so that on the upper side of the cylinder where the fluid as well as the cylinder move in the same direction, the boundary doesn't form. So in this case, there is no formation of boundary layer, but and hence the separation is completely eliminated. So there is no formation means there is a elimination of boundary layer. This is one of the technique. So but on lower side of the cylinder, in other direction, what is there? The separation would exist. Separation is going to occur in other direction. So another technique is that acceleration of the fluid in the boundary layer. So if there is acceleration of because of due to retarded fluid particles and fluid layers, only the boundary layer formation starts developing. And in order to reduce its thickness, we can accelerate the fluid. And in order to prevent it, we can accelerate in greater magnitude so that it can be avoided or it can be controlled. So this method consists of supplying additional energy to the particles, because less energy particles where there is a retardation is existing. In that case only the boundary layer formation will be taking place. So therefore, if you accelerate by supplying the external energy by some means to that less energy particles, so they will become accelerated, and so that there will be less in thickness of a boundary layer formation, or sometimes it can be removed or it can be eliminated. This may be achieved either by injecting a fluid into the region from the interior of the body with the help of some suitable devices. Here in this diagram, so in this diagram, if the if some portion is left like this, and here some device is kept, so whenever the boundary layer is forming, with this device we can inject the fluid into the retarded fluid layers, so that it becomes accelerated. So therefore we have to, so before making the object, if you prepare some portion to keep some device, so that we can accelerate the fluid particles in that area, so that whenever it is forming, if you inject it, then there will be a separation. Or by diverting portion of the fluid of mainstream from the region of high pressure to the retarded region of boundary layer through a slot provided in the body, as in the case of a slotted wing. So in this diagram, for this slotted wing, we can see how it is going to be injected into the mainstream. However, disadvantage of this method is that if the fluid is injected into a laminar boundary layer, it undergoes a transition to turbulent boundary layer, which results in increased skin friction drag. So this is one of the disadvantages with this method. By accelerating the fluid, there is a development of skin friction drag. And another method is that suction of the fluid from the boundary layer. So where the instead of injecting the fluid into the the retarded fluid layers or less energy particles, they will become energized, and so that it can be controlled. But there is a disadvantage also. Instead of that, we can suck the fluid from the boundary layer, so that it can be avoided. Instead of injecting, it can be sucked inside by providing a shootable path into a slotted wing. So in this case also, it can be eliminated. The new boundary layer starts developing, which is able to withstand an adverse pressure gradient also. This is another formation while we are taking inside. So while you are sucking into this pocket, there will be a development of again another boundary layer. A streamlining of body shapes. So with this, we can avoid the formation of a boundary layer. So by the use of suitably shaped bodies, the point of transition of the boundary layer from laminar to turbulent can be moved downstream, which results in the reduction of the skin friction drag. So this is one of the method by which by making the bodies streamlined one. So therefore we can avoid the skin friction drag also. So furthermore, by streamlining of body shapes, the separation may be eliminated. So now, while the fluid, either gases or a liquid, while it is flowing over a solid body, so there will be two types of forces will be generated. That is one. One is a lift and another one is a drag. So in this case, we can see the lift is perpendicular to the flow direction. The flow direction is like this, and lift will be taking the vertical direction, the perpendicular direction to the solid body, perpendicular to the solid body, and perpendicular to the flow direction. The lift will be existing like this, and the drag is the parallel force. So that is parallel to the flow direction. So the line connecting these two forces is called a total aerodynamic force. In case of gases, in case of air, what we call is total aerodynamic force. But in case of liquids, we have to call it as hydrodynamic force. So there is a difference between hydrodynamic force and aerodynamic force. A lift is a component of force that is perpendicular to the oncoming flow direction, and it contrasts with the drag force, which is a component of the force parallel to the flow direction. So drag is a component of force which is parallel to the flow direction, and perpendicular to the flow direction is a lift, and the resultant force is nothing but a total aerodynamic force. A lift conventionally acts as an upward direction in order to counter the force of gravity. So, but it can act in any direction at right angles to the flow. If the surrounding fluid is air, the force is called the aerodynamic force. In water, it can be called as hydrodynamic force. So, in order to counteract the gravitational force, the lift will be acting in upward direction. The lift is defined as a component of the aerodynamic force that is perpendicular to the flow direction, and the drag is the component of force and that is parallel to the flow direction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.